Welcome back. We are going to continue again with our projectile trajectory revisited workbook. And so far we've learned how to do annotations or drawing objects and equations. And the last thing we're going to play with here is charts. And so we're going to insert a couple of different kinds of charts, but before we do so, I'm going to make a little space here in the middle by moving some of these objects over. Now, by the way, how do you move these things? Well, if you just hold down the Shift key and multi-select, you can do that. But if you have something like this, where there's a whole bunch of things to select in order to move, that can be kind of a pain. So if you go over to the Find and Select menu in the Home tab and do Select Objects, it changes the cursor so that, let me try that again. Select Objects, there we go. Now when I drag, instead of selecting cells, it selects objects, and you have to explicitly enable that particular Select Objects mode, and then I can move things over. So now we've got some room here in the center of our workbook, our sheet, where we can create some charts. And charts are pretty easy to use. It's a very fundamental part of Microsoft Excel, an important way to express your data in a graphical format. But when we're dealing, especially with engineering applications, we need to be familiar with the different types of plots. It's very common that people will, for example, use a line or a bar chart when they should be using an XY scatter plot. And to illustrate that, you've got a couple different tables here. One of these is totally unrelated to the projectile trajectory thing, but that's the expenses versus month. And I put this in here just to provide a contrast to the type of chart we want to use for our projectile trajectory. And so let's do that one first. The instructions say to do it last, but we'll do that first. So if I want to create a chart illustrating how my expenses vary by month, let's see, I need to get back into regular cell select mode. There we go. I'm going to select that chart, and I'm going to do Insert. And then here in the Charts section, it gives you a number of different charts. You can also push this little button, select this little icon here, and it'll show you all of the various chart types that you have to pick from. To do something like expenses, you typically want a column chart. Sometimes these are called bar chart. Actually, a bar chart is a rotated column chart. But let's do a column chart to begin with. And that creates a nice, simple, intuitive chart showing how our expenses vary by month. And if we want to change the title, we just click on this and do monthly expenses. There we go. Now, suppose we want to change that to something else. We can go in here and select change series chart type. Go back and say, well, let's make that a line chart. Now, a line chart puts a single value for the actual expenses for that month, and then it connects them by a series of straight lines. What we're plotting here are a series of discrete values as a function of month. And so, yeah, a line chart works great. A column chart works great. Any of those options would work out fine. And it automatically drops in the labels here for my months on the horizontal axis and the expenses on the vertical axis. If you want to change the formatting or the spacing on any of these axes, if you just double click on it, you can do that. You can change by default it figured out it wanted to go every 2000. But you can change the units if you want, and if you want to go with something larger, maybe maybe every $4,000. Let's try that. There you go. So, or you can reset it back to the automatic amount. And there are a number of things here in terms of the formatting and so forth that you can change, but that's pretty intuitive and easy to follow. Now, with that there as a backdrop or an example, let's shift gears and go back to our we have a table here that illustrates how y varies as a function of x in this projectile trajectory equation. So essentially we created a series of time values from 0 to the maximum time, and assuming you're shooting something out of a cannon, and here's a little diagram showing what it's going to look like in general. And then we use these two dynamics equations here to input those t values and calculate a set of coordinates along the trajectory of that projectile. And now we want to actually put that into a chart. The chart type that you would use for this is an XY scatter plot. And so if we do insert, this is the scatter plot section right here. And you can do it as a set of points only, or you can do the points and lines. They're called markers actually. So this is markers only. This is markers and lines, markers and smooth lines, or you can do just the smooth line. And this is markers and straight lines, and this is just straight lines. Now, whenever you're deciding what chart to use, it's important to consider what it is you're trying to represent. In this case, what we have is an underlying set of functions for x and y that define a curve, and we've selected 11 points to depict that curve in the table, but it's just the underlying curve is a smooth continuous function. So I would argue that what you want to use is the smooth lines in this case. Now there are cases where straight line makes sense depending on what it is you're plotting, but I would just encourage you to think about this a little bit. One thing I wouldn't recommend is if you're plotting a function like this and you're just using markers only, that to me that's kind of deceptive. Those 10 points we picked are pretty meaningless other than they're evenly distributed. What they're trying to represent is this underlying smooth continuous function. So I very much would recommend in a case like this you have lines, and if you want to show the markers on the lines, that's fine. I would argue that what we really want to show is this trajectory, and so the smooth lines would work out best. And so I'm going to select that. Now another thing that's really important here is with a scatter plot, you are charting one column of numbers versus another column of numbers. So the second column is a function of the first column, and so the second column goes on the vertical axis, the first column goes on the horizontal axis. That's always the way it does an XY scatter plot. Now, by the way, I didn't select the labels at the top of the chart, but let me do this again, and this time I'm going to select those labels and do insert smooth. And in that case, it says, oh, you must want the name of that second curve to be your title. And I don't really want that in this case, but some cases it could be helpful. But I'm going to just click on this and say projectile trajectory. Now, if you want a label to be used for your X, or if you want a title for your axis here, let me see if there's a way to do that. Format axis. Whoops, I'm in the wrong menu. What you want to do is you want to click this plus sign, and the plus sign allows you to turn on axis labels and some other things, a legend if you want. We only have one curve, so a legend doesn't make sense. But once you have that turned on, you can click here and type this is Y, and this is X, and there you have some axis titles. Now another thing that is really important here is for this particular case, it goes from, or the X values go from 0 to almost 100,000, and for some reason it extended that X-axis labels or markers out to 120,000, and that's fine. Let's assume we change the angle here. Now we're going out to 200,000, and you know, where do you get the greatest distance? Now, by the way, as I change these angles, I'm getting a different different set of numbers by a substantial margin, and sometimes, you know, it doesn't do a great job on those labels. So you can do things to rotate the axis so that they can be and there's a way to make them rotate on an angle. I can't remember exactly where that is now, but another point I want to emphasize is let's suppose we wanted to evaluate what that shape of that curve looks like as we change these angles. Well, when I change that angle, it automatically resizes the chart to match that range, and so the shape of the curve looks about the same, but you get your maximum distance at a 45-degree angle. And so let's suppose I want to fix this, so instead of going from 0 to whatever, it always goes to its specific amount. So if I just double click on that, and I go in here and I say, well, instead of 250,000, I want that to be 200,000. Well, now that's fixed. Once that auto symbol goes away, that maximum distance is fixed. And then if I go in here and I change the angle to 60 or 75 or whatever I want, that maximum distance there, that horizontal axis, the range shown there is fixed. And for this case, that's kind of nice if I'm just playing with it. Now let's do the same thing. You're going to get your maximum height when this is almost vertical, and it goes to about almost 100,000. So I'm going to double click here and say, make that 100,000. I hit enter, and now that's manually set. And so now as I change these angles, both the horizontal and the vertical range are fixed, and I can just cycle through these angles and see exactly how that shape varies. I'm going by increments of 15 degrees, and so you don't always need to do that. Often you're showing one curve and it doesn't change, but if you're plotting something and you're going to be changing the inputs and you want to see how that changes the shape, sometimes fixing the range of those axes can be really helpful in illustrating that. And if you ever decide you want to change it back, you just double click on the axis, click reset, and now it's back to the automatic mode. So you can always do that. Now a couple other things I wanted to mention. Once you have a curve set up, sometimes you end up wanting to add another series, two different curves. For example, let's suppose I create another curve here called y2, and it's going to be equal to this curve plus 20,000 or something. I'm just going to randomly make something up here. And if I want to add that to my chart, if I do select data, and I can come in here and say I want to add another series. So the series name is going to be y2. the x values are going to be the same x values, and the y values are going to be right there. Oops. Need to take away that one there. And so to define a series, you give it a name. I mean, you can just type in a name if you want. Okay. And then you point to the x series and the y series. We're going to use the same x series in this case. And here we go. So now we have two different curves here. And if we want to add a legend here so that we can distinguish between them, there we go. Now we have y and y2 as part of our curve. And if I change my mind later and I want to get rid of it, I just right click and say delete, and I'm back to my original series. And so again, let's review the difference between these two charts. I mean, they look kind of similar. This is a line chart, and it's when you're representing a set of discrete values versus some, months of the year, days of the week, or even another set of numbers, or labels, but they're discrete values. In other words, the expenses aren't a numerical function of the first column. I didn't use the month number 3 to compute these numbers. It's just attached to it in some kind of relationship. Now, on the other hand, a scatter plot is when you have one number that is a numerical function of another number. You use the x, the first column of numbers, to calculate numerically the second column of numbers. So that's why we often call it an XY scatter plot. It's y versus x, and these are really commonly used in engineering. Now, let's suppose that I select these two columns, and I go up here to insert, and I say, oh yeah, a line chart, let's do that. But if I use a line chart when I really should be using an XY scatter plot, what it does is since those are both numbers, it's not going to plot one versus the other. It just plots each of them versus its index, point number 1, or value number 1, value number 2. How come it did that differently here versus the monthly expenses? Well, when you did a line chart of the monthly expenses, it looks at the first column and says, oh, okay, those are months. And it's smart enough to know that those should be labels. But when you just have two sets of numbers, it doesn't make sense. In this case, a line chart would treat each of those two columns as independent series. And so instead of doing y versus x as coordinates, you have a y curve and an x curve, which really isn't what you want. So you got to be careful there. And again, the proper type of chart for this would be an XY scatter plot. So again, there are a ton of different kinds of charts. This is meant to be a brief introduction to those. I'd encourage you to just start creating charts and playing with the different types, and they're going to be a really powerful tool for you.